Hello, my name is Shunzhou. Uh, my project is fitting a linear model to minimize the portfolio variance. The idea is that I chose a stock index and build a linear model to best describe the index and trying to uh, minimize the variance. So the Standard Poor 500 index was chosen. It has extremely low variance because the index has 500 stocks in it. However, if you an investor, it is unlikely to invest in all 500 stocks to minimize the risk. So the goal is to predict the Standard Poor 500 index with just a few significant stocks. And in the end, I will compare the model return with the uh, Standard Poor 500 index return. So the rate of return is calculated by the final price minus the initial price over the initial price. The prior assumption is that the model will be fitted with the SP500 index, and there will be an investment portfolio uh, suggested by the final model. Here's the stocks I used for this project. There are 6 sections of stocks, 6 industries. There are tech industry, services, financial, consumer goods, healthcare, oil and gas. Those 6 industries are basically the main industries, the main sections of the SP500 index. There are 18 stocks, and all the stocks are high cap stocks. The time period used for this capture the is from April 2018 to the end of March 2019. Those data are weekly data and all 52 weeks of the year. This is the weekly final price for data for the SP500 index. We can see the index is continuously growing from April to late September in 2018, but has a significant drop since October 2018 to the end of 2018. However, the stock bounced back since 2019. So these are the time series plots for all 6 industries. We can say most of them have similar trends. They all bit of similar to the index trend, but they have their own characteristics. For example, the tech group and the service group, they all have a decline in the middle of the year, but the dropping point is different. But they all kind of like the Standard Poor 500 index. However, there are some different stocks that didn't obey the trends. For example, Coca-Cola stock and the MRK stock from healthcare group. The MRK stock actually was the best earning stock of all the 18 stocks I've chosen in the database. So now we fit a simple linear model to the data set. The y here is the SP500 index, and all the xi's are the 18 stocks, and the betas are the parameters. Beta 0 is the intercept, and beta 1 through beta 18 are the coefficient of all the stocks. Here the intercept is given around 400 points, and on the second column the coefficients are given. Some of them are negative. That means they have negative effects to the index. And to the very right hand side of the graph there are stars. The more stars it has, the more significant of the stock. So we don't have a 3-star stock here, but we have a few 2 stars and a 1 star, and a couple stocks that are significant but not significant enough. Those values are suggested by their p-values. So the 2 stars they have less than 1% of p-value, and those stocks that are not significant, they have a p-value of over 5%. So in here the initial model, we have 4 2 stars and 1 star. Here is the principal component analysis of the dataset. There are in total 19 principal components for each stock and also the index. And here I plotted the first two principal component, and this graph explains 41.8 plus 35.3. It's roughly 77% of all information contained in this data set. And if their arrows are pointing to the same direction, that means those stocks are very similar. So we can find the SP500 stocks right over here, and it has a few stocks that are very similar to it. For example, Amazon, ConocoPhillips, ExxonMobil, and there are also other directions. For example, the Facebook is very distinct from other stocks, and the Coca-Cola is at the opposite side of Facebook. That would suggest as at least the Facebook and the KO, their stock trends are quite distinct. So here's a verification of the principal component analysis. If we chose some stocks that is pointing to the same direction as the SP500 index, and we calculate their returns. Here we only calculate the stock returns only when the SP500 index increased at that week. So the first picture here, we have 3 stocks, Apple, Amazon, and Exxon. Their annual return is given by the second column, which for Apple it's 10%, for Amazon it's 24.5%, and for Exxon it's 8%. However, when the SP500 their 500 index increases, their relative return are increased from 10% to 38%, from 24% to 79%. And when the SP 500 index decreases, those three stocks are also decreasing. Notice the gap. They all have a huge gap when the index increases and decreases. For Apple is almost 70%, and for Amazon it's over 100%. So that means those stocks has a positive correlation with the index. And this works within stocks too. So if we choose two more other stocks, for example the Conco, the annual return of the stock is 4.6%, and Google is pointing to the same direction as the COP stock. And when the Google stock increases, the COP stock, the rate of return increases from 4.6% to 37.4%. And when Google stock decreases, the ConocoPhillips stock also decreases for 32.8%. And that works for Google and Apple stock too. So Apple, Google, ConocoPhillips, Amazon, ExxonMobil, they all in the same direction with the SP 500 index. Now let's look at a example of the opposite direction. So we can see from the previous plot, the Facebook plot, Facebook is pointing up, and Coca-Cola is pointing down, the KO. And now we'll look at the return of KO. The annual return for KO is just 8.9%. When Facebook stock increases, the corresponding KO stock increases to 14%. And when Facebook decreases, Coca-Cola also decreased for 5%. Although it still seems like a positive correlation, but the magnitude has dropped significantly. There are only 20% difference when Facebook stock price decreases to increases, and that proves they don't have such a strong positive correlation. So now we want to choose the stocks for our final model. We chose all the stocks that have stars from the first model, and we get Amazon, Bank of America, and Exxon, and we verified it at the right hand side, and it proves they are all very significant to the model. Now I would like to use Markov chain Monte Carlo method to build this model. So the MCMC method is a base method. It gives the prior data, which are the data we collected, and for all the parameters we will assume a density distribution, and the Markov chain Monte Carlo method will give us a parameter sampling, that is a simulation of the parameters, and finally we'll have a distribution of the parameters and estimates. And in order to decrease the autocorrelation of all the parameters, we will central all the data. So here the model is zy equals zeta 0 plus zeta 1 times zx1 plus zeta 2 times zx2 plus zeta 3 times zx3. The zy is the centralized SP500 data, and the ZXIs are the centralized stock data. So the centralized data is calculated by the original data minus their mean data and over their standard deviation. So in the end, we have to transfer all the zetas back to the betas, which was our original parameters. So in the end, after the transformation, we'll take all the constant as beta 1, take the parameters in front of x1 to be beta 1, so on and so forth. And here we have the result after the Markov chain Monte Carlo method has been run for 3 chains, 10,000 variations. And we can see the density distribution for all 4 parameters. And down there, there are the quantiles for each variable. For beta 0, which is the intercept, the 95% credible interval is from 609 to 915, and the parameter value for Amazon stock is from 0.24 to 0.37, and the point estimate for the other 2 stocks are 19 and 11.89. Here we have the model plot. The blue plot is the real valued standard pool 500 index, and the fit model is plotted in red with the dotted lines. We can see it fits nearly perfect with all the parameter values. So now we calculate the rate of return. The rate of return for SP500 index for the last year is 8.8%. So that is the market return of last year. If we consider SP500 index as a minimum risk. So now we times their proportions to their stock mean value, and it will be over the portfolio value to calculate the true proportion. So in the portfolio, the Amazon stock will will be 26.2%, and BAC will be 27.4%, and XOM will be 46.4%. And the rate of return of the portfolio is each stock's proportion times their rate of return, and the value is calculated to be 11.4%. That means we find a model that fits with the SP500 index perfectly. The combination of the 3 stocks can fairly represent the index. So the variance goes with the trend of the model, and therefore the variance is predicted to be very low, and we have a rate of return that is higher than the SP500 index. So the conclusion here is all the stocks in this dataset are high cap stocks. Those stocks are very stable and reliable. In general, they will the price will not fluctuate up and down too extreme. However, to achieve this low variance, the return was also relatively low. For the last year's stock return, the BAC stock was one of the lowest rate of returns of all the 18 stocks, and the rest of the stocks have an average rate of return of around 20%, and the MRK stock from healthcare, it has a rate of return of 60% last year. But in order to minimize the risk, those three stocks were chosen. And the three stocks were chosen are from three different industries. They are from services, financial, and oil gas. So that means the diversity of the variables, it has a diversity in the variables, and it could be a good presentation of the SP 500 index. Although the MCMC method calculates similar parameter values to the simple linear model, the reason is because for those three stocks were chosen, they fits very perfectly to the linear model already. The MCMC method is very good at eliminating the effect by outliers. So if we use all 18 stocks, the MCMC method will be much more accurate. However, the parameters calculations will be much harder. Thank you.